Aloha, Richard Halverson here. This is ICS211. And in this video, I'm going to help you along with lab 17.3, the recursive binary search. So let me share my screen. All right, so it's this one. And we're just supposed to implement a recursive version of binary search. And it makes, you know how binary search works, is it takes the middle index and sees if the target is equal to the middle index. If not, if it's greater than it resets the lower index to the middle index +1, and if the middle index, the value at the middle index is greater than the target, then that means the target is in the lower half, so it resets the upper index to the middle index -1. That might not have made that much sense to you, but let's just go through this and see what it says and implement it as it says it. Parameters, it's just got a target integer and an array list of integers, and the upper and lower bounds of the sorted array that it is searching. And it's going to either return the index or it's going to return a -1 if it wasn't found. There's a template down here. It's now it wants you to after it works, it would like us to count up the number of calls to binary search and count up the number of comparisons, except for don't count this last comparison there where you are looking to see if you've exhausted the search and we're unable to find the the value, the index of the value, because it wasn't in there. All right, so and this is kind of tricky because they want you to implement it in a certain way. So when you run it on this data, you get these numbers, and it's kind of tricky how you count comparisons and how you count recursions to get these exactly right. So you can't just throw any working recursive binary search in here. You got to kind of do it so based on more or less what they say up here, so you get the counts come out right. All right, so this is the program. This is what they give you, and you load up an array list. Now first you enter how many numbers in your array, and then you read in the array, and then you read in a target. Oh, here, where is it? Here, a target. And then you do the binary search to try to find the target. And you start the binary search, and the binary search is going to return the index of the target or -1 if the target is not in the array. And so this is the array. This is the array. And we start the binary search where the low index is 0 and the high index is the last integer in the array. In other words, integer the size of the array -1, which is the index of the last integer. And you start the binary search there, and this ends up being a recursive algorithm. Each time it calls itself, it'll be either by increasing this to the midpoint +1 or decreasing the upper index to the mid index -1. So the code goes right here. And so the first thing we're going to do is we're going to figure out what the mid index is. So I'm going to say int mid is going to equal to the upper index plus the lower index, which is this one and this one, divided by 2. And to get these, to get the counts right, to get these counts right, let's take care of the case where we've actually found the target, or we've or lower has gone past upper. In other words, lower ends up being it comes in here and lower is greater than upper, or upper is less than lower, in which case you know that the target is not in the array. So first we do this, and first let's see if we actually found the target. So we do if target equals the array of integers dot, I think it's get mid. If the value at the midpoint is equal to the target, then we have then we can simply return the midpoint, because we found it. In other words, we found it. Otherwise, let's check right here if lower has gone past upper. In other words, if lower is greater than or equal to upper, then we know that that the target is not in the array. So I'm just going to return -1. Okay, so this is one comparison right here. And by the way, I guess we have to declare these comparison, and we have to do static int so it works. Static integer, because it's not going to be static integer comparisons, and we'll initialize it at 0. And let's do the recursions also. Static integer recursions equals 0. And a recursion is whenever this is called. So we can actually put that right up here. As soon as we come in, we know it's been called, and we can increment recursions. And okay, so this is one comparison. We test to see if we found it, or if this is the case. We don't really count this case, because this case is only tested once at the very end. So we sort of wrap it in with this case. It's this comparison plus 1, basically. So it says here, don't count this case, but this is actually a bug. If you have equal, it's gonna not work. So this is, you have to put greater than or equal to. Anyway, okay, so that's one comparison, and you don't need to count this one. So it's just 1. This whole thing is 1. The other, and then the next comparison is it's not the target, and lower is still lower than upper. So we do it's another comparison. And we are saying if the target is less than integers get mid. If that's the case, then if the target is underneath mid, then we got to set then we have to set upper, then upper equals mid -1, because the target is below. The target is below the otherwise, we know the target is not equal to this, because otherwise we would have caught it up here. So the else case is simply that the target is greater than the middle, in which case we have to reset the lower. So lower equals mid +1. Wait a second. No, wait a minute. No. Oops, I'm getting my static. I'm getting my that is set to that, and then we have to call the binary search. Uh, um, index. Oh no, return binary search target. You gotta send that down. We gotta send down integers, and we send down lower and upper. So this gets reset, and so it's a new upper, it's the same lower, and this one down here is we reset the lower and call this again. So we either return the index that, let's see, is this gonna turn out? I think this is gonna be okay. All right, let's see, I'm just gonna try to run this. Comparisons plural. This is plural. And this is plural. Let's try it again. All right, that's pretty good. I'm pretty sure that this will work with other test data, the way that these comparisons are being counted and the way that the recursions are being counted. And so I'll let you confirm that. And that does it for lab 17.3. Hope this helps. Thanks for watching.